minutes west. Flight level 330. This is 271, over.
In recent tests, position accuracies of less than 1 mile error have been achieved. Results of this work could lead to advanced techniques for satellite position fixing and traffic control, and aid in the solution of some of the world's transportation problems. Space geodesy has taught us the true shape of our planet, where it flattens, how much it bulges. With these results, we are better able to map the Earth and to navigate. The orbital path of a satellite is not a perfect circle. The satellite weaves sideways and up and down as it travels its course around the Earth. These deviations are measured only in feet, but they can be detected by Earth-based tracking stations and reveal new facts about the Earth's structure. Satellites have been tracked by laser. After predicting where spacecraft will be at any given time, telescope-mounted lasers swing into position, and aided by computers, their pulses of light lock on and track the orbiting craft. 3 of NASA's Explorer satellites carried special reflectors that mirrored the laser light flashes. The positions of the satellites were precisely determined, and the distance calculated simply by measuring the time it takes the beam to go to the satellite and return. Precision in satellite tracking leads to precision in terrestrial mapmaking. The Department of Interior estimates that the value of up-to-date topographic maps is worth nearly $700 million annually to our national economy. On the North American continent, surveyors have laid out a grid enabling them to locate any point with respect to another within 30 feet. There are similar grids in other well-developed countries, but they are not tied together. A surveyor cannot see over the ocean with his transit to make the connections. But a satellite can. It is a valuable tool because of its altitude. Observers several thousands of miles apart can see a high-flying satellite at the same time. By making simultaneous measurements with optical and radio tracking instruments, they can determine just how far apart they really are. The current goal of satellite geodesy is to tie all geodetic grids together to within an accuracy of 30 feet. Using high-flying satellites as geodetic markers, the world's continents will eventually be tied together to one common reference system. Geodesists also hope to use their new techniques to keep track of polar ice caps and glaciers, monitor the geometry of the ocean surfaces, increase knowledge of how earthquakes occur, and make direct measurements of the rates of continental drift. As the world's population continues to grow, our need to develop, protect, replenish, and use our natural resources wisely becomes more apparent and urgent. The air and atmosphere are resources of the Earth, as are the oceans, fresh water, ice packs, forests, minerals, and usable land. Efficient utilization of these resources not only includes their discovery and management, but also detection and control of pollution. In many areas, this need is reaching crisis proportions. Concerned citizens, private industry, state and federal agencies, all are seeking solutions to the problem. New techniques are being discovered to help. NASA has been exploring the use of both manned and automated spacecraft to develop the potential of flying instruments in space that will permit unique observations of the condition of our agricultural, water, forest, mineral, land, and marine resources. Much research has been done with aircraft, with information from existing satellites, and of course from the valuable photographs taken by the astronauts of the Mercury, Gemini, and Apollo programs. Based on this experience, it appears that the vantage point of space offers a number of unique possibilities for surveying Earth resources. The first 2 unmanned Earth resources satellites are planned for launch, one in 1972 and one in 73. They will provide a regular timber inventory of the earth, identify crops, their vigor and yield, make automatic soil classifications, take photographs of the sedimentation flow patterns of the world's waterways, and help in locating mineral deposits. Here are some views recorded from planes and from Earth orbit by spacecraft. Better surveys of food and forest areas can be made from space, with computers distinguishing the conditions of the various types of crops and soils. Infrared photographs can show the onset of insect disease in forests. The damaged trees show up blue-green in color, the healthy trees red or pink. An Apollo spacecraft orbiting 150 miles over northern Australia spotted forest fires. Here are two others, as seen from space southwest of Tallahassee, Florida. By viewing fresh water from space, lake colors can be correlated with the biological, chemical, sediment, and pollutant content. Glaciers are another important source of fresh water, and their growth and decline are very sensitive indicators of the available supply. The Bureau of Commercial Fisheries says there is a close relation between fishery production and the temperature of the ocean, and they're very interested in having more accurate spaceborne instruments developed for monitoring these thermal conditions. This could significantly improve the efficiency of fishing fleets. Space photography can assist in mapping navigation routes in coastal and shoal water areas and help control silting in major harbors and navigable rivers. Ultimately, spaceborne instrumentation may permit observations of the wave heights of our oceans. Although it will not be possible to acquire all of the needed Earth resources data by sensors located directly in the satellites, it is possible to supplement the information by placing surface instruments, such as buoys, water gauges, and strain gauges, at strategically located positions on the surface of the Earth. These surface instruments could transmit the data to satellites, which would then relay it to central data handling stations. The Nimbus weather satellite is playing a role in ecology right now. A recording system on Nimbus was developed for an animal tracking experiment. Scientists attached a specially instrumented collar on an elk in western Wyoming. As Nimbus flies over, it receives information about the elk's condition and location and reports back to Earth. Accurate tracking of free-roaming animals in their natural environment will increase scientific knowledge of animal migration habits and may show ways to help protect our wildlife population. This is Skylab, America's first manned experimental space station. It will be launched into orbit around the Earth in 1972. There are several Earth observation experiments planned for the orbiting space station. One of the men who hopes to be flying in Skylab is scientist-astronaut Dr. William Lenore. He too is interested in Earth resources.
One of the more interesting aspects of what we can learn from space, I think, is the Earth resources area, which generally is tied up in the kind of things that I can learn from space by being in Earth orbit, looking back at the Earth from a remote sensing point of view. Meteorologically, we've seen many things already. We can learn about the Earth's surface from a crop survey standpoint, where the surface water is and the immediately subsurface water for the water management for the world. Pollution control and studies as to where the pollution is being emitted from and where it goes to. Fish industries for the ocean and sea states for ocean-going vessels, icebergs. I think these are just actually very few of the types of things that we can monitor and study from space on Earth resources. The Skylab program is going to be stepping off in this direction.
Bringing space down to Earth continues to make a substantial impact on our way of life. Communications satellites routinely provide reliable telephone service on a global basis. and important events are brought into our living rooms through intercontinental television. Coming close to reality, satellites that broadcast news, educational and cultural programs to populations of entire nations. Meteorological spacecraft aid in daily weather predictions. Satellites for navigation and traffic control will help make better economic and safer use of air corridors and oceans. Earth surveys from space should offer another means of preserving natural resources. We are sharing many benefits from space right now. As we develop this potential in the future, applications from space will have continued, profound, and direct effects on our everyday lives here on Earth.
Every year, climbers travel to the Himalayan mountains in hopes of celebrating at the top of the world. Sometimes referred to as our planet's third pole, this region holds some of the world's most iconic and challenging terrain. However, this landscape is changing. Many of the glaciers on popular trekking routes have retreated and given rise to new and larger glacial lakes, which typically form when glacial meltwater is blocked by ice dams or glacial sediment. And worldwide, retreating glaciers have led to an increase in the number and size of these glacial lakes. Researchers, supported by NASA's High Mountain Asia program, use new supercomputing abilities and hundreds of thousands of Landsat satellite images to catalog and analyze 3 decades worth of glacial lake boundaries in the first ever global study of its kind. The study found that, during that period, global glacial lake volume increased 48%. The analysis concluded that, worldwide, smaller glacial lakes were growing at a more rapid pace, and that lakes were occurring at higher elevations than previously documented. This new assessment is a critical component to understanding how these growing lakes may impact tourism, elevate hazard risk, and affect infrastructure for the communities living downstream, and bring us one step closer to understanding the global changes to our cryosphere.
deploy command sent 2339. Atlantis, Houston, the pocket's terminated to deploy command. We did not get the motion we expected. We've terminated the command so the motors don't overheat.
I can reach the boom from here if you want me to just try pushing on it some from here.
Atlantis, Houston, you go for release.
Cleared the tower.
Exactly 24 hours ago. You've been there for 1 day now.
On orbit, here's a couple of tourists. We put the manipulator on through the loaded operation for the first time ever. Liftoff. Liftoff of America's space shuttle on its first mission, and we have cleared the tower.
I'm sitting in the left-hand side, it's referred to as the commander's seat. Looks good on the IS indicators, we're going to LDF deploy. Copy that.
Now flying high above the Kennedy Space Center.
Today, as you flawlessly executed the LDEF retrieval, millions paused from their daily routines. We quietly watched America's space program at its very best.
The spacecraft is stable. Galileo is on its way to another world. It's in the hands of the best flight controllers in this world. That's definitely the orbiter. What you're seeing, the flashing, is me turning the flashlight on and off.
Are you serious?
Absolutely. Houston Discovery, we got it.
The unique latches on the diagonal members of this truss allow the mechanism to deploy bay by bay out of the mass canister to their full extended length of 60 meters or 200 feet. That's about the length of 5 school buses.
Atlas is studying the Earth's atmosphere, and what we're trying to find out is what chemicals are present and in what altitude.
Controllers here at Goddard Space Flight Center, approaching the opening of the release window.
Columbia, we see a good deploy.
Good deploy. Congratulations. Great job on deploying Legios.
Houston Discovery got a good job on the part. Copy that. Great job, Steve. Simple flashing lights goes through the optic nerve up into the brain, and we can literally track these well into the brain. There are a number of other items that we have on board, but all of these are aimed at giving us a better understanding of the way weightlessness is affecting the nervous system.
Scientists are looking very carefully at the reasons why astronauts have difficulty sleeping on orbit. This research, in addition, could prove very helpful to people on Earth who suffer from sleep disorders. On Neuralab, crew members are acting both as operators and subjects of this rotating chair, which is designed to stimulate the vestibular system. These may also have an Earth application in that they may help scientists design more effective rehabilitation procedures for patients who have severe inner ear diseases.
Now in the Space Hab module, which is in Discovery's payload bay, with Japanese Space Agency astronaut Chiaki Mukai in the foreground, and behind her, European Space Agency astronaut Pedro Duque. And he is joined now in the Space Hab module by Mission Specialist number 2, Scott Parazynski.
We're in the process of putting in the FSF.
Outstanding. The best procedure that we can come up with is to use the flight water.
Okay, I got my little grubby hands on it. Now you just kind of let me take it where I want it. All right, better.
Houston, Dan, do you have the IntelSat in sight?
Roger, we sure do, and it's right under crosshairs. All got a good grip? Yes, sir. Houston, I think we got a satellite.
Houston, we show vestibule pressurization complete. Please coordinate with the Mir crew for the leak check.
Houston and Denver, we have captured target.
The maneuver that I was supposed to say, yeehaw!
Houston, we're clear for a 5 cycle.
5 coming.
Here we are in the cupola of the International Space Station, where we can get a great view at the whole bottom of Space Station, which of course includes a wonderful view of Atlantis.
Hi, I'm Nikki Fox, and I'm in charge of all sun science here at NASA. This is Ask NASA, and I'm here to answer your questions. Is the sun a ball of fire? No, it's not. We know that the sun can't be a ball of fire because we need oxygen to be able to have combustion, and there's no oxygen in space. The sun, however, is a giant nuclear furnace. The core in the very center is very, very similar to a nuclear reactor, and all of these particles get squashed together, and there's a huge amount of pressure, and they undergo chemical reactions, and so there are very different layers as you move out towards the edge of the sun. Why does NASA send missions to the sun? Because the sun is the most important thing in our solar system. The sun generates light, but also a tremendous amount of energy, and it sends all of this material to us here on Earth. And so we live in the extended atmosphere of the sun. We've looked at the sun in every different wavelength, but recently NASA launched the Parker Solar Probe, which is a daring mission to go into the very atmosphere, the very heart of the atmosphere of the sun. So I have a model of the Parker Solar Probe spacecraft here. Could I get some sun in here, please? So the important thing is, as the spacecraft moves around the sun, the heat shield has to remain pointed towards the sun at all times. So the heat shield, the front of the heat shield, will get to about 2,500 degrees Fahrenheit, but the main body of the spacecraft is nice and cool at about 80 degrees Fahrenheit, which is a bit like a balmy Florida evening in August, I guess. And that's Parker Solar Probe. Thank you. Good. I don't know how polite you are. So one of the things that we discovered with Parker Solar Probe on the very first orbit was switchbacks. Switchbacks. If only I had a model of the corona. Ah, thank you. So switchbacks are really reversals in the material coming from the sun. So the sun has a magnetic field, and that is continually moving away, or so we thought, continually moving away from the sun. But what we found with Parker Solar Probe is this magnetic field actually kind of reverses on itself and makes an S shape, and we call that a switchback. It's hard to twist a magnetic field. It's like trying to twist a rubber hose. It's hard, and so somehow there's this energy going into the magnetic field that's causing this S shape, and when it releases, it's letting all of this excess energy out into the solar wind. Thank you. Studying the sun is really important as we get ready to support the Artemis mission. We're really protected here on the planet by our magnetic field and all of that atmosphere around us. Our astronauts, when they will be on the moon, and of course as we journey further to Mars and beyond, we'll be traveling through the solar wind and living really more in the atmosphere of the sun. And so it's key as we go forward to the moon, to Mars and beyond with our Artemis mission, that we really understand the source of energy in the heart of our solar system. Parker Solar Probe on her final closest approach after she's done all of those Venus flybys. She will be at about 3.9 million miles above the sun's surface. We have many materials on Parker Solar Probe that don't melt despite how close they are to the sun. In fact, that was one of the big technology challenges for us, to find materials not only that don't melt, but can actually withstand the incredible change in temperature, because Parker goes very close to the sun and then comes out around the orbit of Venus, which means that all these materials go really hot and then really cold at least 24 times. So the critical thing for Parker Solar Probe, of course, is to keep that heat shield pointing at the sun. At some point, she will run out of fuel. At that point, unfortunately, she will start to turn, and the full illumination of the sun will hit parts of the spacecraft that are not designed to see the sun. And so she'll break up into large pieces, and then they will get gradually smaller and smaller until they become really tiny. And so I like to think that she will become part of the corona, and she will orbit the sun forever. So honestly, we don't know what new science we're going to expect. We've already seen unbelievable stuff on our first couple of orbits. Science is a voyage of discovery, and that is what Parker Solar Probe is doing. She is going into a region where we've never been before. And so honestly, we expect the unexpected. My favorite aspect about the sun is it's a star, and it's a star that we can go and visit. And so you think, you look up in the night sky, you see all of those stars, and yet we're actually sending a spacecraft right into the atmosphere of a star right now. And that means we're going to understand more about other stars in our universe, and that's amazing.
Do you have a question for NASA? Send your questions to our experts on Twitter using hashtag AskNASA.
We are in a very remote environment. It's a harsh environment. You move slower, you're tired, your eyes hurt because it is so bright out there. You're cold, you can't remember the last time you were warm. And to, kind of make matters worse, you're digging giant holes in the snow. So you're working hard the whole time that all of these elements are just pounding on you.
The SNOWX project is really a multi-year campaign to test different instruments and techniques for observing snow characteristics in different regions and different snow types. So we collect measurements on the ground with different ground-based instruments and observing techniques. We use that to validate instruments on aircraft and in the air, and eventually hopefully get some instrument on a satellite.
One of the advantages of Grand Mesa is its elevation. We're at over 10,000 feet here, and so as you can see, the snow is not wet at all. And so we want to start by really proving the concept in dry snow. A lot of the remote sensing approaches are also challenged by complex topography, so really steep topography. And as you can see, where we're standing here, we're on the top of a mesa which is relatively flat. This is the largest mesa in the world, and so it's a pretty unique spot to do this work.
Within the pits, we're looking at the vertical stratigraphy, so the layering of the snowpack and the different characteristics of those layers, temperature, density.
I'm operating the snow micro penetrometer, which is one instrument that they use in the pit crews to look at the hardness of the snow and to look at the microstructure.
The microstructure is a very important characteristic for these active passive microwave retrievals, so we wanted to get that in a lot of locations.
I've just done a radar survey in a particular way, and we use this type of sampling strategy. We're calling it a Heimstra spiral. It's a spiral pattern. I'm making 100 measurements per second as I drive the snowmobile, and that is a very similar measurement to what's happening on the aircraft.
SWISAR really stands for Snow Water Equivalent Synthetic Aperture Radar and Radiometer, and it's actually two instruments in one. It has an active radar and a passive radiometer. Basically, they both work on the microwave frequencies. And what they do is to penetrate the snowpack a little bit and give us the volume scattering information, then which we can relate to how much water is inside the snowpack.
Snow water equivalent is really the volume of water that's stored in the snowpack. For hydrologic applications, that's really the most important characteristic. We want to know how much is available to melt and where it's going to go, evaporate into our groundwater reservoirs, and how much is available.
Our climate's also changing, and snow is playing a really big role in that. And it's a big piece of the hydrologic cycle that's quite uncertain, and it's one of the pieces that we really see as a very high priority to get more quantitative, more accurate estimates for.
Snow is a really important part of our planet. It provides water, hydropower. It's a water source for agriculture and water supply.
When we have snow in our mountains, it's holding it and it's kind of like timing the melt in like a slow release versus just an onset of rain or a flood event.
As we build these records for longer time series, we would be able to tell how the snow accumulation is changing over a given area and how that might impact the agriculture in that area or how the people live in that area.
I'm really excited about the potential right now. I think there's a lot of excitement in the snow community. There's a lot of collaboration. I think we really are at a point where we can push the science forward and move towards a global snow product and a satellite mission, hopefully.
There's various benefits to integrating unmanned aircraft into the national airspace. A couple of them are being able to monitor specific weather systems, also monitor fires over specific areas of the country or world. They're also able to fly longer durations than some manned aircraft out there. The smaller platforms are able to help in various ways as well, such as delivering packages to your doorstep. The UAS and the NAS project has had various campaigns. For Flight Test 4, we utilized the Icana, which is a MQ-9 Predator B platform. And from there, we were able to test larger UAS and also larger sensors. Flight Test 6 is based off of smaller type UAS platforms and sensors. We flew the Navmar Applied Sciences Corporation Tiger Shark Block 3 XP. We started with system checkout flights, moved on to some basic radar characterization, which we collected a bunch of radar data. And then we moved into the scripted encounters portion where we specifically tested the detect and avoid system. And then from there we were ready to start our full mission. For the full mission aspect of FT6, we utilized both virtual traffic, which was a simulated aircraft, and then we also used a live intruder aircraft as well.
We're at 6 miles.
5,500. We had a ground control station that was only for the Navmar Tiger Shark. We also had a mobile operations facility 5, in which remote pilots were also able to man that station and control the aircraft. And then we also had Mission Control Center 3, where the test conductor controlled the intruder aircraft and the Tiger Shark. And we also had the live virtual constructive environment at Armstrong, and it connected Ames and Armstrong together. Through the sensor suite that was on board the Tiger Shark, all of that data was telemetered down to the pilot, and he was then able to make any corrective maneuvers through the detect and avoid display and system. We're collecting data for the FAA and also RTCA. With the completion of Flight Test 6, from all the data that we're able to collect, they're able to inform minimum operational performance standards for integrating UAS into the national airspace.
Song, not necessarily my #1 relative. With that comment, I guess I better be packing my bags. Here's Ricky with a song that's quickly taken over the #1 spot. He must have insulted his mother-in-law, too.
I'm a traveling man, made a lot of stops all over the world.
Before a joint session of Congress today, President Kennedy gave this country a remarkable challenge.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth.
Did you hear that?
Are we going to the moon? That's what the president said.
That message by President John F. Kennedy, May 25th, 1961, brings back many memories. But it really hit home for the people of South Mississippi when the government announced 5 months later, to the day, that it would build a test facility along the banks of the East Pearl River to test those rockets that were going to the moon.
The newspapers throughout the area carried the announcement of the location of the test site. Generally, quiet, settled community. It was a lovely place. I was somewhat familiar with the fact that Honey Island Swamp between the two Pearl Rivers was sort of a no man's land. Also, Devil's Swamp over to the east of the site here was just in low timberlands. The original policy for acquisition of the test site was the operational area where all of the facilities are constructed contained 13,500 acres. That was bought outright, including the mineral interest. The buffer zone, which was approximately another 120 plus thousand acres, the original policy was to acquire only a perpetual restrictive easement.
One of the reasons this area was selected, of course, it was a number of reasons. The physical reason for one thing, this marvelous river we had here, and then low population. Where could you find that much acreage and move that smaller amount of people?
The project was under overall management of the Marshall Space Flight Center in Huntsville, Alabama. And the people up there were really excited about the selection of this Pearl River area for the test site. After all, it was just a short distance down the Pearl River and across the inland waterways over to the Michoud Assembly Facility in New Orleans, and out the mouth of the Pearl and around the tip of Florida to Cape Canaveral, where you would launch the rockets. But even though the area was sparsely populated, NASA did have to move 5 communities to make way for the construction of the facility. They were Westonia, Santa Rosa, Napoleon, Gainesville, and Logtown.
The Gainesville community was a unique community. The Lovelace grocery store, Mrs. Louise Lovelace, who operated the store with her husband, was sort of a focal point in the community. Around the corner from the grocery store, there was a lady, and I don't remember her first name, but she was referred to as Aunt Blue. Her name was Aunt Blue Davis. When we acquired her home, as a lot of the others did, she didn't have it demolished, but she reserved the right to remove it. And she had a house mover. As I recall, his name was Daley Dronette from the Gulfport area, who loaded that house and took it up around the Nicholson area. Aunt Blue Davis never left it. She sat on the back porch in a rocking chair and went down the highway with that house. And I can still see that lady today, and I think she had maybe a niece, I believe Mrs. Freeman Davis, that rode with her as that house went down the highway up Old 43 to the Nicholson area.
A lot of us look on Senator Stennis as more of a statesman than a politician. Yeah. He told us that if any of you have any trouble dealing with the Corps of Engineers on doing the eminent domain, you call me and I'll see what I can do. And he did help people who called him. It was a daytime meeting, and the way they handled the questions and answers, they had couriers, and I was one of them. People, if they had a question they wanted to ask, they had to write out the question, and then we would take it up to the podium. I don't know who the lady was. I took her question up, and her question was, why do we have to go to the moon? Senator Stennis answered that question in this way. He said, we have to go to the moon for international prestige.
Senator Stennis had another quote that day that became rather famous. He said, there's always the thorn before the rose. The thorn being eminent domain, the rose being the opportunity that those people had to play a major role in America's prestigious space program.
I was highly elated, very proud of America. I felt that, I'll tell you why I felt that way. I felt that we were part of it. Since we had given up our land and moved and everything, that we were actually part of going to the moon.
We had the challenge of building a very large rocket test facility. It was a swamp here. There wasn't anything here except the Rushan house, which is behind us. The challenge was significant. In today's dollars, that would amount to $1 billion facility. We had to build it from scratch, and when it was completed, it was going to test the awesome Saturn V rockets that were going to take men to the moon.
Jerry has been associated with Stennis Space Center for almost its entire existence. In the Apollo days, we used to see Jerry once a week as he flew down from Washington, where he was responsible for overseeing the construction of the Mississippi Test Facility in those days.
There were schedule problems. The S2 stand was a critical facility, was determined to be the most critical facility in achieving the Apollo mission. And therefore, there were lots of pressure to complete the construction on schedule.
We did not know at the time what all it took and what all it was going to take to really construct and to put together the type of facility that's required to support the space program. But as time passed and as we continued to work and continued to lay out the boundaries and the foundations for construction, the roads began to appear, power lines began to appear, buildings began to appear, then it started coming together.
We had to clear an awful lot of land. We had to put in an awful lot of facilities, many of which were very highly technical facilities, very high pressure systems and liquid oxygen and hydrogen that was going to be required, and the test stands over to a little further to the east of us. Our responsibilities for us in the early days was to construct the facilities, get it to a point to where it could be operable. And all during those days, it took about 3 years for us to finish and finalize all the facilities that's now known as the Stennis Space Center.
The construction activation phase brought out the very best of everyone. It was characterized by superb leadership. Dr. Werner von Braun, director of the Marshall Center, appointed a Navy captain, Bill Fortune, as first project manager. Captain Fortune was highly respected by his employees and especially popular in the communities. The first American flag to fly over this site, symbolizing NASA's presence here, was raised by Captain Fortune and Dr. von Braun. That event brought on a reminder of Dr. von Braun's early involvement with this facility. He was not merely an overseer or a visitor. He was a participant. In fact, he often referred to this South Mississippi site as his baby.
You know, he was a fine gentleman and a true professional and really knew how to get everybody's consensus to his ideas and how to move them forward. And Carl Heimberg and Bernie Tessman, his deputy, were in charge of his test laboratory up there in Huntsville. And we worked very closely with them developing the requirements for this facility. Carl was a hard driver, but a very, very tough and fair man, very focused on where he wanted things to go. Tessman had a good personality, had a good sense of humor, and he filled in some of the people gaps, but both of them were fun to work with. And of course we had Henry Order, and a gentleman named Gordon Artley was significant in bringing together the focus to get this place activated with 3,000 or 4,000 new employees coming on, plus 3,000 contractors, and get things done. Ken Riggs was outstanding in bringing together the test experience and requirement to our planning team.
Some people think I'm kidding when I tell them that during the month of July we had to wear a jacket, a denim jacket or some other form of jacket that was thick enough to prevent the mosquitoes from penetrating your clothing.
Rainy season, there was a lot of mud, and so that slowed things down. When we excavated for the test foundations, there were holes 40 feet deep, and so you got down to where water wanted to just bubble in the bottom, and we had to put in more deeper and deeper wells so that we could pull the water table down. Congestion, I mean, there was work going on everywhere here, and just lots of activities happening simultaneously. We had that snow, about a 10-inch snow down here in Mississippi.
We did have some unusual problems during construction and sometimes resorted to resourceful methods to solve them, even to the point of using mules to do what modern machines couldn't accomplish. One of the photographs taken of that activity became world famous.
That picture was real famous. That picture went around from coast to coast, they told me. My boss asked me, say, "Do you know how to plow a mule?" I told him, "Yes, I do." It was kind of wet, soggy. Mule was kind of boggy, but we made it.
In the spring of 1965, Jackson Balch was appointed manager of what was soon to be officially named the Mississippi Test Facility, and with him he brought other leadership from Huntsville to fulfill the mission.
Jack Balch asked me if I would come down and be a project manager on the S2 program, and it just looked like an opportunity I couldn't turn down. Working for Jack was a real learning experience too.
Jack Balch was a unique character, a lovable man in many ways, a tough taskmaster in many ways. He certainly would be an understatement on my part to say that he left an indelible mark here.
Again, he was a hard-nosed individual, but you like Jack automatically if you like competence, because he was a very competent individual.
It was just the people more than anything. People tend to remember the hardware, but it's really the people that made the hardware work.
There was considerable excitement in the air in those days with the anticipation of building and testing the vehicles that would get us to the moon. People were being trained. We were learning how to handle large volumes of hydrogen. It was an exciting time for sure.
Everything was out of the ground facility-wise. We were putting in cables, terminating cables. S2 was getting ready to finish out at Seal Beach and be shipped in here, and it was just a real beehive of activity getting ready for the first test. And as you remember, the S2 was probably the most controversial of the Saturn V stages, in that it was liquid hydrogen, had a common bulkhead, and expected a lot of problems.
Well, it was pretty difficult because we were running round the clock, no days off. You know, it wasn't anything like a weekend. You just kept right on going. Coming up to the test, everybody was pretty tired, but I can remember the feeling that they certainly wanted to get it off.
The rocket testing started in 1966, and every rocket that was tested here performed its mission flawlessly in flight in taking our men to the moon.
Like all Americans, I remember it well. Being at home with my family, keeping my kids up all night so that they could see this historical moment, and then finally seeing Neil Armstrong step on the moon and having a sense of pride that I had some little small part of that. All the people here at MTF in those days, as we call it, the Mississippi Test Facility, felt an enormous amount of pride in the fact that we had a major role in making that happen.
The people at MTF and their neighbors didn't have long to enjoy the laurels of that fantastic mission. Even as the nation was celebrating that first lunar landing, an ill wind was brewing in the Gulf of Mexico that would change the destinies of thousands of people and the directions of the Mississippi Test Facility.
Camille came along, devastated the coast, killed several of our employees, damaged our facilities, and it was a time when our people came together. Hurricane Camille focused the attention of the country on this area. And NASA bowed its back and said, we want to help in this area. And NASA provided substantial help to the area, not only by continuing the operations here, but in many other ways in the local community.
The MTF management team, under the leadership of Jackson Balch, was engaged in a diligent search for new roles and missions even before the tragedy of Camille.
When we started hearing about the Mississippi Test Facility and the fact that the rocket testing was phasing down here, we were asked to think of things that could be done here. Assistant Center Director at Johnson Space Center, Bob Powlin, was asked to define an activity to be implemented here. And he defined this laboratory.
NASA established the Earth Resources Laboratory at MTF, and a number of federal and state agencies were also invited to utilize the facilities.
A plan was set out to